All right, there we go. All right, so let's take a walk down memory lane, right? Because one of the big things in Algebra 1 was all about lines, all right? You did all the things. You graphed the lines. You told me about the lines. You wrote equations of lines. What are some things you remember about linear equations from algebra? They are a line. Do what?
Symmetric.
They can be symmetric.
Asymmetric.
They could be asymmetric.
Horizontal.
They can be horizontal. They can be vertical. What makes them do all those things?
Being online.
No.
I think no.
Mm-mm. There's one characteristic that makes them either be horizontal or vertical or tilted. That's slope, right? They have a slope, okay? So slope refers to the steepness of our line, okay? So it has a slope. It refers to our steepness of that line, okay? Does anybody remember how to find slope if you have the 2 points? Yeah. Yeah, if y's on top, x is on the bottom. It's like a picnic table, right? If the y's were on the bottom, the table would fall over. Yep. And then we had slope-intercept form of the line. That's what most people remember. Yeah. Slope-intercept form of y equals mx plus b. M is the slope. What was the b?
The intersection.
Y-intercept.
Alpha, Rebecca.
That's really good.
Okay. And so that's kind of what we remember from Algebra 1. Most people, when I say, tell me something about a line, mx plus b, like, it's like the one thing. We're not really sure what it means, but we know it. Right? Exactly, right? We just beat you senseless with it in 8th grade and freshman year, right? So, yeah, there's no escaping it. All right. Well, the good news is, in statistics, we still use mx plus b, but we don't have to calculate it ourselves anymore, which is really nice. And then we use lines to predict what's going to happen in data, okay? And one of the other nice things is they kind of reverse the order, and I'm going to show you why they do that here in just a second, and how they talk about the slope and the y-intercept. But that's all we're really going to talk about today is a slope and a Hey, turn that computer off. We're not watching that right now. We're doing math. Thank you very much. Y'all have just lost your mind because fall break starts this time next week. Law.
3 days in a week.
We're going to make it. We're going to make it. All right. Hang tight. All right. So here's what we're going to do today. We're going to make predictions. All right. Using regression lines, keeping in mind the dangers of something we call extrapolation. I'm going to tell you what that means here in just a second. We're going to calculate and interpret what's called a residual. That's an important measure that we're going to use. And then we're going to interpret the slope and the y-intercept of a regression line. Okay, so it's going to give me an equation, and we're going to talk about what does it mean in the context of the problem. All right, so let's jump back in here. Good old Barbie, God love her. Okay, God love her. You know, she's been jumping off this bungee thing for a while now. She's getting a headache. All right. And so here's some data from the groups, okay? And it wants us to calculate the regression line. Well, I'm just going to go ahead, instead of us putting it in, because we're not really going to do that today. We're going to do that tomorrow, all right? I'm just going to give you the equation. We cool with that? Okay, save us a second, right? This is what it's going to say, all right? And I want you to notice the notation they use. You see, they put a y and they put that little caret above it, okay? They call that y hat, all right? Because it looks like a hat. Okay, they call it y hat equals 25.33 plus 7.46 x. Okay, go ahead.
Okay.
Yeah, use that corner.
Okay.
I'll take it if you want me to.
It's like a,
That's okay. They always get us in the wrong spot. It's for you. I put that equation into the applet, and it would spit it out for you. Yeah. We're not going to have to do that part today. We're going to do it tomorrow. All right? But you know how we went to the applet, the two quantitative variables, right, where we were calculating correlation? We'd go to that same applet, calculate correlation, and then underneath it, it says calculate regression line, and you'd hit enter and it'd pop it out. Okay? But that's what we're going to do tomorrow. All right. So no worries about that. All right, so I want to talk about it for a second in terms of how they describe it. Y'all almost cut my finger off last night. Not really. Have y'all seen those new choppers on TikTok that are like rectangular and they have the screens and you take like, if you want to chop up stuff and you take it, you slam it down? Okay, so I bought me one. They're really awesome for chopping like onions and vegetables and all kinds of stuff. So I was making a soup yesterday and I go to chop my onions. Well, then I get ready to go to clean it. Okay, and it says, be careful with screens, extremely sharp. Okay. So I'm using my squirt, my spray hose in my sink to try to spray the onion. It won't come out. So then I've got this little tool and I'm scrubbing it. Well, as I'm scrubbing it, I slip. And y'all, I probably need stitches, but I was just too lazy to go to the doctor last night because it wasn't really a good story. But anyway, it bled forever and ever and ever. I finally got to stop this morning. So anyway, I still have a thumb though. Life is good. Okay, so if you get one of those, be careful. It's legit really sharp. Okay, so. Luckily, it was when I was cleaning and not when I was actually cutting, so we didn't end up with, finger in the soup. That would have been gross. All right, so they refer to this as y hat. It is our prediction equation. Okay, it is our prediction equation. It's what we're going to use to predict within the data set. All right, so we can use it to predict what's going to happen. Okay, notice they switch the order. Okay, they put the y-intercept first in statistics and the slope second. Okay, it is still mx plus b, but they do b plus mx. Okay, so they just switch it around. So y hat is always the y-intercept plus the slope times x. That's just a statistical thing. It's the exact same linear equation you're used to writing or seeing. They just switch the order. Okay, because statistics needed to be weird. All right. Now, the good news is, all right, once we have that equation, it allows us to make predictions. Okay, so if we look at that next question, it says predict, use the line, so we're going to use that equation, to predict the distance traveled for 5 rubber bands. So let's think for just a second. Which one of those variables represents the rubber bands, the x or the y? The x. Okay, so this is x, and that's my y hat, my distance. So I'm going to take this equation, y hat equals 25.33 plus 7.46, and instead of x, I'm going to pop a 5 right there. Okay, that's all we're going to do. All right, we're just going to replace the x with that 5. Now, this is where I want my calculator, okay? Your 10 fingers might not have been enough, okay? And you got 10 toes, right? So 25.33 plus, we can type it in just like it's written, 7.46 times 5. And it gives me 62.63. What are my units up there for distance in the table? Centimeters. Okay, centimeters. Right. So that's how we use the prediction line. All right, we're just going to plug a value into it and get an answer. All right, and we'll use our calculator to do that. Now, we go on, it talks about that one of the group members later found that the actual measurement for 5 rubber bands was 64. So if we went in here to the table at 5, it would actually be 64. Okay, and it wants to know, was the prediction from number 2 too high or too low? Okay, we got 62.63. Is it too high or too low?
Way too high.
It's too low. Okay, it's too low. And so what we're going to do, this is a value that we refer to as the residual. Okay, we take the actual value and we subtract the predicted value. Right? So the actual value was 64. Minus 62.63, which was what we had. And the result gives me 1.37. That 1.37 is my residual. Okay? It's how far the prediction is from the actual value. Right? A residual is how far something is from the actual value. Okay? And we always find it taking our actual value minus our prediction. Is it possible we could get a negative number there?
Yes.
Yeah. Okay, and it's kind of backwards from what we would think because we said too low, but what kind of answer did I get? I got a positive answer because that's what happened. Okay, so if it's ever below the actual value, you're going to get a positive number. If it's ever above, you're going to get a negative, which is kind of weird. But you can always just look at the two numbers to know if it's above or below. Okay, which is nice. Okay. So let's take a look at number 4. Again, just making predictions, all right? Predict the distance traveled for 20 rubber bands. Okay, well, let's go in here. Let's use our line. All right, who are we going to put 20 in for?
Rubber band.
For the rubber bands, which was X. So 25.33 plus 7.46 times 20. So we'll use our calculator again, all right? So we're going to need it. 25.33 plus 7.46 times 20 gives me 174.53 centimeters, okay? Now, that's a pretty big number, right? If we look there at our data, what was the largest number of rubber bands we put on Barbie? 7, okay? We'd probably need to know how far it was to the floor where she was going, all right, to know. But do you have more or less confidence in this prediction than you did when we did it for 5? Less, all right? Why less?
Because she probably died.
Yeah, I'd say she probably hit the ground running, all right? Like splat, right? That's a lot of rubber bands at 20, okay? This is an example of what we call extrapolation, okay? So here's a big word. Extrapolation, all right? We say it extrapolation. Extrapolation means I'm making a prediction way outside my data set, okay? The largest number of rubber bands we had actual data for was 7. 20 is a long way away from 7, okay? So extrapolation is to predict outside the data set. Okay, and we want to try to avoid that if at all possible, all right? Doesn't mean it won't be accurate, all right, but it's just more dangerous. We're going to have less confidence in that value than we would something that was within our data set. Hey, your friends brought your stuff. That was so kind.
I was just kind of having a rough day.
It's
I went
okay.
to look for them because I thought they had it. But
Oh, it's all good. We gotcha. Okay. All right. So now we've hit 2 of the lesson targets. Can we make a prediction? Plug in an X value into the equation. That's what we're going to do. They're going to give me the equation. Can we find a residual? All right. So that actual value minus our predicted value. Be careful predicting outside of a data set, right? It could give us some really weird numbers. And so the last thing we want to talk about is how do we interpret the slope and the y-intercept in the context of the problem? What does it mean, okay? So let's take a look. What was the y-intercept of that regression line that they gave me? Remember, they wrote it backwards. What was the y-intercept?
Oh, 25.
Yeah, it was the 25.33 number, okay? It's 25.33, okay? And what that represents is the distance when there are 0 rubber bands. Okay, so if Barbie just fell over the side and hung there with no rubber bands, that's how long she would be. In other words, that's how tall she is. Okay, she's 25.33 centimeters, right? If we just dangled her by her feet, all right, no rubber bands, okay, that's just how tall she is because I got no rubber bands on her, all right? She's not bouncing. She's, begging for mercy, okay? Then the slope, okay? One of the things we need to remember, which number in the equation represented the slope? It's always the number next to x, okay? And what slope is a rate of change, okay? It is a rate of change. Okay? Because it's positive, that means my distance is going to increase 7.46 centimeters for every rubber band that we add. Okay, so understanding that rate of change, okay? Another way to think about it is centimeters per band, like if you wanted to put a unit on there. Y units over X units, all right? My Y units, my distance was centimeters. My X units, my top row was number of rubber bands, okay? So it tells me how fast or how much the distance changes. If it was negative, all right, if it was negative, the distance would do what? Decrease. Okay, so positive, it's going to increase. Negative, it's going to decrease. So just learning to look at what it's telling me in the problem and then go from there. Okay, so just interpreting in context what that line means. That's really what we're doing today. Plugging in things for X, finding the difference between an actual value and a predicted value, and then telling me what the slope and the y-intercept mean. Okay, so the only thing you really need the calculator for is to do the predictions. All right, so let's consolidate all of this information, okay, on the back. Look at a couple of examples, and then we'll be ready to rock and roll when we get back from lunch. Okay, so not difficult today. I think your assignment's only got 4 problems.
How many problems does the test have?
I can't remember. I'll have to go back and look.
Okay.
Yeah. On Thursday, we're having the career fair. We go first thing. So as soon as we get in here and I take attendance, we'll go to the career fair. It's on Thursday, and then we'll do our test after lunch. So, yeah, I was glad. I was like, oh, yay, we're first. So we'll do that and then go to lunch, then come back and take our test. So it'll be nice. Okay. All right, rock and roll. So, use my phone. All right, let's organize these thoughts really fast, okay? So, learning target 1 was about making predictions, okay? All right. Basically, we're going to plug X into the equation. That's it. Okay, and my prediction equation is always y hat equals b plus mx. All right, be careful with extrapolation. Okay, we don't want to be extra bunch. Okay. Okay, so just be careful with extrapolation. It may or may not give us good data. Okay. We don't want to plug in something too terribly big and outside of my data set. Okay. Learning target 2 is the residual. All right. How do we get it? Well, we just take the actual value minus the predicted value. Okay. And it tells me how far we are above or below the actual value, right? And that's what we use a residual for, right? So there'll be one where it'll just ask you to calculate that number, okay? And it's just a simple subtraction, right? The actual value minus the prediction. Okay, and then learning target 3, all right, was to interpret slope and y-intercept. Your y-intercept is always going to tell you the value of y when x is 0. Okay, it's kind of like our initial value. What are we starting at? All right, we're starting with that much stuff. The slope is always the rate of change. In y for 1x. Okay, it's the rate of change in y for 1x. How much are we increasing or decreasing each time? Okay, so that's all we need to be able to do today. Can we use the equation to make a prediction, plug a value in for x, let the calculator do the work? Can I find a residual, the actual value minus my prediction? Okay, it tells me if I'm above or below the actual value. And then interpret our slope and our y-intercept. Our y-intercept, okay, it's that y value when x is 0, and our slope is that rate of change in y. How much is y changing for every 1x? Okay. Now, if you look at this, y'all, first of all, who can grow flowers in here? Because I can kill a silk plant. I'm impressed, right? When I had my surgery, my church sent me this beautiful plant. Yeah, it's dead. Dead. The one that I have back here that's alive, Miss Craddock takes care of. She comes and gets it, waters it, feeds it, all the things, because I just can't do it. All right? I want to be able to grow my own vegetables and all that. No, it'd be a waste of money. I'd just kill it all. Okay? But apparently, this is talking about that cut flowers benefit from putting sugar in the water. Now, y'all, do you see all these words? There is tons of words in here. Okay? But let's get down to the last sentence. Let's look for what's important based on what we've been talking about. Okay? Here's a scatter plot along with the regression line. Oh, get you some lunch. We'll finish when you get back.